All right, so we're going to start our motion unit with defining some variables, and x is going to be the position, and that's going to usually be in meters, not always. And we're going to define it as where you are relative to a predetermined origin. Okay, so like I might be 30 meters east of the doorway to my room. All right, delta x, we're going to call distance or displacement. And we're going to talk about the difference between those two in our next lesson. And that's going to be in meters. Okay, delta x can really be defined as change in position. And to find a change, we subtract. So we're going to take our final position minus our initial position. T is going to stand for time, and that's usually going to be in seconds. And then V is going to be speed or velocity, and that's usually going to be in meters per second. We use these two words kind of interchangeably in English, but in physics they have a difference. And again, next class we're going to talk about the difference between the two. Now, the equations we're going to use are very simple. It's just going to be V with a line over it is delta x over delta t. And V is going to stand for average speed or velocity. And I'll talk about what I mean by that in a bit. And I can rearrange this. I'm basically kind of cross multiplying and solve it for position instead of speed. All right, so here's our first example. And the way to do these, and for these you may be able to do them in your head, but when we start to get more complicated problems, it's a good idea to identify our variables. So we got a car traveling at 30 miles per hour. That's our speed. So we're going to call that V. And up above, I said V is usually in meters per second, but it can be in miles per hour as well. And our time is 40 minutes. And we're looking for how far. That's going to be distance. That's going to be delta x. All right, now I have a problem here. My times are in different units, so I got to change that. So I'm going to convert this minutes to hours by dividing by 60, because there's 60 minutes per hour. And 40 divided by 60 is 0.66 repeating hours. Now I can go back to this equation here. And delta x is going to be 30 times 0.66 repeating. And if I plug that into a calculator, I'm going to get 20 miles. All right, the next one, I'm going to draw a little sketch for this. Sometimes sketches help. All right, we have the football player starting on the 50-yard line, and he's going to run down here to the 20-yard line. All right, now let's draw a little guy in here. All right, so his initial position, that's his starting position, is going to be 50. And his final position is going to be 20. Okay, so that was part A. Then part B, we want to find his displacement. Displacement is delta x. And up above here, I said we can do that by doing your final position minus your initial position. So it's going to be 20 minus 50, and we get minus 30 yards. That minus meant that he was going to the left here. Okay, so sometimes direction is important, and we're going to deal with that more in the next lesson. Then C, we want the average velocity. So we could use this version of the equation up here, delta x over delta t, and I get minus 30 yards. And it took 3.6 seconds. And that's going to give me an average speed of 30 divided by 3.6. And I get 8.33, so minus 8.3 repeating yards per second.